All right, I'm back. We're still on page 325. We're going to do this new problem. If you recall, we just found all of these asymptotes. We reviewed how to justify an asymptote, basically the definition of an asymptote. So sometimes its limit as x approaches c, and you get infinity or negative infinity. Other times its limit as x approaches infinity or negative infinity, and you get a constant. So let's see if we can do this problem. All right, rational function. If it's a rational function, then we know that the limit to infinity and negative infinity will be the same, so we just do one of them. So the limit as x approaches infinity of it. We just do one of them, and if you're the type of person who chooses negative infinity, like, I just don't know you. Like, what are you doing? Like, if you have a chance to go to infinity rather than negative infinity, take it. All right, divide through by the highest power of x in the denominator, which is x squared. So that's going to give me 1 minus 2 over x minus 3 over x squared all over 2 minus 1 over x minus 15 over x squared, which is 1/2. Okay, so what's 1/2? It's the horizontal asymptote. So therefore, y equals 1/2 is horizontal asymptote. Okay, now we want to do vertical asymptotes. So vertical asymptotes, zeros of the denominator that don't cancel out, they're definitely going to be the vertical asymptotes. It's all about justifying it. So here, let's rewrite f of x. F of x. Pretty confident that we can factor everything here. So go x and x. Minus 3 plus 1 is really the only option here. So I have to do 2x and x. That'll get me 2x squared. And then negative 15, I'm thinking that I'm going to go with plus 5 minus 3. Plus 5 minus 3 gives me negative 15. And I get negative 6x, 5x, negative x works. Okay. So, oh, look at that. So this reduces down to x plus 1 over 2x plus 5, provided that x is not 3. Interesting. Okay, so let's do a sign chart for this reduced version. So the removable discontinuity at 3 is not on the x-axis, so I don't have to worry about a sign change there, which is like one of the finer points, I guess, of doing this kind of thing. So I need to put negative 5 halves. It's really important that you put them in the right order, otherwise it doesn't make any sense. So negative 5 halves and negative 1. I know that negative 5 halves is the vertical asymptote. I'm just trying to justify it. So negative a billion gives me negative over negative, so positive, which is actually all I need. I mean, I'm going to finish, but that's all we needed, right? Because we just need the limit from the left or the right to be infinity or negative infinity, and we had enough information there. So I'm going to say the limit as x approaches negative 5 halves from the, let's do the right. I mean, why not? Of f of x is negative infinity. Therefore, x equals negative 5 halves is vertical asymptote. There is no horizontal asymptote. There's a removable discontinuity at x equals 3. 3. So let me, if I were to do this, so take this up here and do the limit as x approaches 3 of f of x is going to be the limit as x approaches 3 of x plus 1 over 2x plus 5, which is 4 over 11. 6 plus 5, 4 over 11. So there's a hole or removable discontinuity at 3 comma 4 over 11. All right, I feel like we should check this on the calculator because we have the ability to do that and cannot highlight for you how much you should be doing that. Every time you do a problem, just check it on your calculator. Let's see, doc for new problem. Let's store f of x is x squared minus 2x minus 3, 2x squared minus x minus 15. Okay, so what are we going to do? Limit, basically we're running through the same thing we did last time. Limit to infinity is in the pi key, but like I can just type it. I get 1/2, perfect, so that's the horizontal asymptote. I'm going to do the domain thing. domain of f of x, -5/2 and 2. All right, so let's do the limits again. Limit as x approaches -5/2, and we chose from the right, and we got infinity. And it got, oh no, we got -infinity. Whew, my bad. So we got that correct. I just said it incorrectly. And then to check the other one, what I could do is I'm just going to check the limit as x approaches 3. It should give me, it doesn't matter which side because I'm pretty sure the limit exists. It should give me 4/11. And it does because there's a removable discontinuity there. All right, so we nailed it. Let's go back to the notes and do this last problem on this page. But we are getting very close to the last problem in the notes, which is the last problem in math analysis. And that is crazy because this course is this is a marathon and a sprint. It's like sprinting a marathon. All right, so let's see. This is not a rational function. So we have to go to infinity and -infinity. Not rational. So your first thought should always be, is it rational? Because that's less work. This is not rational, so we have to go both directions. So here we go. The limit as x approaches infinity of f of x is the limit as x approaches infinity of 3 plus 4 to the x over 2 minus 5 times 4 to the x. All right, so I'm going to divide through by the highest powered thing in the denominator, which is definitely 4 to the x. 4 to the x dominates everything. So I'm going to divide everything I see by that, and then kind of logic my way through it. So 3 over 4 to the x plus 4 to the x over 4 to the x is 1. 2 over 4 to the x minus 5. Okay, so if 3 over x goes to 0 and 4 to the x grows faster than x, then 3 over 4 to the x must go to 0 even faster. So that's going to be 0. Same logic for 2 over 4 to the x. So really, I'm just left with -1/5. So that's the limit to infinity. So that's a horizontal asymptote. Therefore, y equals -1/5. It's horizontal asymptote. All right, good enough. Now we got to go to -infinity because it's not a rational function, so different things can happen. Limit as x approaches -infinity. Let's make this bigger. Of f of x is the limit as x approaches -infinity of 3 plus 4 to the x. I don't know why I always do this step. I think it looks good. That's why I do it. Okay, so to do this, what I always do is I think of the graph of 4 to the x. All right, so 4 to the x looks like this. And you can tell that the limit as x approaches -infinity of 4 to the x is 0, which means when I find this limit, 3 has no x's in it, so it's just going to be 3. 4 to the x is going to 0, over 2 has no x's. -5 times 0 is just 0, so this will be -0. So 3/2 is another horizontal asymptote. Sorry, yes, that's right, horizontal. Y equals 3/2 is horizontal asymptote. Okay, we're almost done. But now the question is there a 0 in the denominator? And if so, can we work out like positives and negatives? Like hopefully we can. So let's take a look at that. So 2 minus, so for vertical asymptotes, first I need to solve 2 minus 5 times 4 to the x equals 0. Then I need to work out some limit, either the limit from the left or the right. We're going to probably do that graphically, I think, because I have a sense of what this graph looks like. So this will be subtract 2, divide by -5. So I get 4 to the x is 2/5. So then I'm going to say x, natural log of 4. So I took the natural log of both sides and brought down the exponent as a coefficient. So x is the natural log of 2/5 divided by the natural log of 4, whatever. Okay, so I use natural log because calculus only works with natural logs. It doesn't really work with other bases. If you have another base, step 1 of any other base is convert to natural logs. So why not just start with natural logs? All right, so I think the graph, it's basic. So you have 4 to the x, which is like this. you move it, you reflect it, and then you move it up 2. So it's kind of like this. Okay. And then 3 plus 4 to the x is always positive. So I'm looking, the reason I'm thinking of 3 plus 4 to the x right now is because I'm thinking of this up here. So 3 plus 4 to the x, always positive. In the denominator, if I approach this value, so I'm going to say like, let this equal a, right? So this is a. So the limit as x approaches a from the left of f of x is a positive number from the shaded in f of x. The numerator is positive. The denominator is approaching 0, but through the positives. So it's a positive divided by a really infinitely small positive, which is the same as a positive times infinity. So we get infinity. Therefore, x equals a is, ooh, crazy. Let's get rid of that. Cut. Is a vertical asymptote. All right. So it's a little messy because A is particularly strange. So like this part and this part, just to make sure you realize like what A is. I'm going to go to the calculator and see if we got any or all of this right. Hopefully all, but hopefully, definitely hopefully any, and preferably all. All right, so f of x is 3 plus 4 to the x over 2 minus 5 times 4 to the x. Okay, so limit to, we have to go to positive and negative infinity. Limit as x goes to infinity. That's not, I didn't spell it right because it didn't go, it didn't do that. Infinity of f of x. Oh, look at that. I forgot to, I didn't define it, right? I just did equals, not colon equals. Should have said done. That was a tip off when I like looked at it and I was like, that looks funny, because it didn't look like done. Negative 1/5, which we got. Nice. Let's go to negative infinity. So always copy anything you can copy and paste on the calculator. Do it. It's just faster. 3/2. Awesome. Okay, so let's get the domain of f of x. Okay, so we have that, and now we want to check the limit. So that is the same as ours because the natural log of 4 is, I'll go back to the notes and I'll like explain why that's the same. So let me show you how we can rewrite this, because this is where natural logs, so logs in general, really annoying, right? Because there's a million ways you can write them. So let's do it in, yeah, I guess this color is okay. The natural log of 4 is equal to the natural log of 2 squared, which is 2 natural log of 2. Also, the natural log of 2/5 is the same as the natural log of 5/2 to the negative first, which is the same as negative natural log of 5/2. So that's what the calculator has done to us. It gave us negative natural log of 5/2 over 2 natural log of 2. I don't know why it did that. There's kind of like no rhyme or reason, actually, as to why it does those things. But we just need to check the limit for this. So the limit of, let me do that thing where I take the right part of the answer. Okay. And now I'm going to do the limit as x approaches the answer from the left, I think I chose. I did, of f of x. And I got infinity. I'm a little nervous about this one. Infinity. Woo! So it's a vertical asymptote. So we did it. All right. So that problem is non-standard. If it's not rational, then it's just like going to be more work. But we did the work and we got it right. And so that's a pretty good deal. All right, so what I'm gonna do is I'm gonna end this video here and I will be back in the next video to keep talking about stuff. So I will see you then. And I hope you're finding this helpful, like honestly, because it is tons of hours in my life. I think I'm up to like 33 hours at this point, but that's fine because hopefully people are learning. So I will see you in the next one.